Welcome back to the AI Risk Manager interview prep series from Fortivance Academy. Episode 4 is about the frameworks and methodology that hold an AI risk program together, the NIST AI Risk Management Framework, the ISO 42001 and 23894 standards, and the practical work of building taxonomies and programs. Over 6 questions, we'll cover how to explain the NIST RMF in 2 minutes, how to reframe the false choice between NIST and ISO certification, how to design a risk taxonomy people actually use, how to sequence the 4 functions when standing up a program from nothing, the dangerous assumption that framework compliance is a legal safe harbor, and a behavioral question about building structure out of ambiguity. Foundational to curveball. Let's get into it. We open episode 4 on the framework that anchors US AI risk practice. An executive wants the 2-minute version. What's tested? Can you describe the NIST AI RMF cleanly? 4 functions: govern, map, measure, manage, with govern as the culture layer that runs through all the others. And can you say what it's for? A voluntary, flexible way to build trustworthy AI across the whole life cycle, not a checklist and not a law. A strong candidate also names that it defines trustworthiness through characteristics like valid, safe, secure, accountable, explainable, privacy-enhanced, and fair. The trap is reciting the 72 subcategories or treating it like a regulation with teeth. Voiceover. I'd start with what it's for, not its anatomy. The NIST AI RMF is a voluntary framework for building trustworthy AI across the entire lifecycle: design, development, deployment, and monitoring. It's a way of thinking, not a checklist and not a law. Structurally, it's 4 functions: govern, map, measure, and manage. Map is understanding context and where risk lives, measure is assessing and tracking it, manage is acting on it, and govern is the culture and accountability layer that runs through all 3. It also pins down what trustworthy actually means: valid and reliable, safe, secure, accountable, explainable, privacy-enhanced, and fair. The one expectation I'd set with the exec is that it's descriptive, not prescriptive. It won't hand us the answers, so the real work is tailoring it to our specific systems and risk appetite. To lock in question 1, avoid the traps on the left, they're what quietly sink candidates, and hit the 4 points on the right for a confident, defensible answer. Next up, question 2. Question 2 attacks a real and common confusion. Leadership thinks NIST and ISO 42001 are competing choices. What's tested? Do you understand they do different jobs? NIST AI RMF is a voluntary framework. It shapes how you think about and structure AI risk. ISO 42001 is the world's first certifiable AI management system standard. You can be independently audited and get a certificate that satisfies procurement and stakeholders. They're complementary. Many organizations use NIST to shape the program and pursue ISO 42001 to demonstrate it. A strong candidate also slots in ISO 23894. The AI risk management guidance, not certifiable, which is the methodology companion to 42001's risk clauses. The trap is picking one and missing that they answer different questions. Voiceover. I'd tell leadership it's the wrong question. These aren't competing options, they answer different questions. The NIST AI RMF is a voluntary framework. It gives us the structure, the 4 functions, and the common language to actually build and run an AI risk program. ISO 42001 is something different. It's the world's first certifiable AI management system standard, which means an accredited third party audits us and issues a certificate. That certificate is what customers, procurement teams, and regulators increasingly ask to see. So the smart play is both. Use NIST to shape how we manage AI risk and pursue ISO 42001 to demonstrate it externally. And sitting underneath both is ISO 23894, the AI risk management guidance. It's not certifiable, but it gives us the methodology for the risk assessments that 42001 requires. Different tools, one integrated program. To lock in question 2, avoid the traps on the left, they're what quietly sink candidates, and hit the 4 points on the right for a confident, defensible answer. Next up, question 3. Question 3 moves from frameworks to building something. A risk taxonomy is foundational plumbing, and a bad one is just a word cloud of fears. What's tested? Do you build something usable? The strong approach doesn't invent from scratch. It borrows structure from established taxonomies like the NIST Gen AI Profiles 12 risk categories and ISO 23894, then adapts to the firm's actual systems. It organizes risks so each one ties to a real impact, a likely owner, and a control, and it distinguishes AI-specific risks, bias, drift, explainability failure, confabulation, from inherited risks like data privacy and security. A great answer stresses that a taxonomy only earns its keep if people can actually map a real system to it and act. The trap is an academic list nobody uses. Voiceover. The failure mode here is a beautiful taxonomy that's really just a list of scary words nobody uses, so I'd build for usability from the start. First, I wouldn't reinvent the wheel. I'd anchor on established structures like the 12 risk categories in the NIST Generative AI profile and the guidance in ISO 23894, then adapt them to our actual systems. Second, every risk category has to earn its place by mapping to a real impact, a likely owner, and a candidate control. If a category doesn't point to action, it's noise. Third, I'd separate the AI-specific risks, bias, model drift, explainability failures, confabulation, from the risks we inherit from any tech system, like data privacy and information security, because they're managed differently. And finally, I'd pressure test it by actually classifying a live model against it. If a model owner can't map their real system to the taxonomy in a few minutes, it's not done. To lock in question 3, avoid the traps on the left. They're what quietly sink candidates, and hit the 4 points on the right for a confident, defensible answer. Next up, question 4. Question 4 is the implementation question. Knowing the 4 functions is table stakes. Sequencing them into a real program is the skill. What's tested? Do you start in the right place and treat it as ongoing? The strong answer starts with govern. Policies, roles, risk appetite, accountability, paired immediately with an AI inventory because you can't map, measure, or manage what you haven't cataloged. Then map, context, and risk identification per system. Then measure, assessment, testing, metrics. Then manage, prioritize treatment and monitoring. And critically, it's a loop, not a line. You revisit each function on a cadence as systems and guidance evolve, and you can layer the Gen AI profile for generative systems. A candidate who treats it as a one-and-done project misses the point. Implementation typically spans 6 to 18 months. Voiceover. The order matters more than people think. I'd start with govern, but paired with an inventory, those two together. Govern means standing up the policy, the roles, the risk appetite, and clear accountability. And the inventory means cataloging every AI system we actually have, because you genuinely cannot map, measure, or manage what you haven't found yet. With that foundation, I'd run map, understanding each system's context and identifying where its risks live. Then measure, assessing and testing those risks with metrics that track them over time. Then manage, treating the prioritized risks and monitoring them in production, worst first. The crucial part is that this is a loop, not a one-time project. We revisit each function on a regular cadence as our systems and the guidance evolve, and we layer the generative AI profile on top wherever we deploy generative models. Realistically, it's a 6 to 18-month build to maturity, not a quarter. To lock in question 4, avoid the traps on the left. They're what quietly sink candidates, and hit the 4 points on the right for a confident, defensible answer. Next up, question 5. Question 5 is the advanced curveball, and it's a trap baited with something that sounds reasonable. Council wants to treat framework compliance as a legal shield. What's tested? Do you understand the real relationship between voluntary frameworks and liability? Following NIST and getting ISO 42001 certified genuinely strengthens your defensibility. It's evidence of due care, but it is not a guaranteed safe harbor. And the sharp, current detail. Colorado's original 2024 AI Act actually did offer an affirmative defense for NIST or ISO 42001 compliance, but that law was repealed and replaced by SB 26-189 in May 2026, and the safe harbor did not survive. So a candidate who confidently says, yes, we're covered, is both legally naive and factually behind. The mature move is to correct counsel gently, position the frameworks as risk reduction and evidence of diligence, and avoid overpromising to leadership. Note, the candidate isn't a lawyer and frames it as informing the legal discussion. Voiceover. I'd push back carefully and respectfully because I'm informing the legal discussion, not overruling counsel. Following the NIST AI RMF and getting ISO 42001 certified genuinely matters. It's strong evidence that we exercise due care, and in litigation or an exam that evidence is valuable. But it is not a safe harbor in the sense of immunity. Voluntary frameworks reduce liability exposure, they don't eliminate it. And I'd bring a current fact to the table. Colorado's original 2024 AI Act actually did offer an affirmative defense for organizations that complied with NIST AI RMF or ISO 42001. But that law was repealed and replaced in May 2026, and the framework safe harbor did not survive into the new statute. So treating compliance as guaranteed cover is both legally optimistic and factually out of date. My job is to make sure leadership hears this materially reduces our risk and proves diligence, not we're covered if it goes wrong, because overpromising legal protection is itself a risk. To lock in question 5, avoid the traps on the left, they're what quietly sink candidates, and hit the 4 points on the right for a confident, defensible answer. Next up, question 6. We close episode 4 with the behavioral curveball tuned to program building. Standing up AI risk frameworks is exactly create structure from nothing, so this question maps perfectly. What's tested? Structured thinking under ambiguity and the pragmatism to ship a working version 1 instead of polishing forever. A strong star answer is specific, a real program or process the candidate built without a template, and shows the moves. They didn't freeze, they borrowed proven structures and adapted them. They started small and iterated rather than waiting for perfect. They brought stakeholders in to pressure test and they measured whether it actually worked. The best answers admit the first version was imperfect and improved with feedback. That's maturity, not weakness. Avoid the perfectionist who over-engineered and the person who had no method at all. Voiceover. I'd answer in star form with a real example. A time I was handed a mandate with no template and no precedent and had to build the structure myself. The first move was not freezing in the ambiguity. I went and found the closest proven structures, adjacent frameworks, how other teams or firms had solved similar problems, and adapted them rather than inventing from a blank page, because reinvention wastes time and reliability. The second move was shipping a deliberately imperfect version 1 quickly and then iterating with real feedback instead of polishing a perfect framework in isolation that might not survive contact with reality. I brought the people who'd actually use it in early to pressure test it, and I made sure I could prove it worked, a concrete signal that the structure held and got adopted, not just that it existed on paper. The honest part of the story is that V1 wasn't right, and it got materially better because I treated feedback as the design process, not a threat to it. To lock in question 6, avoid the traps on the left, they're what quietly sink candidates, and hit the 4 points on the right for a confident, defensible answer. That closes episode 4. In episode 5, we get technical, bias, drift, explainability, agentic accountability, and vendor model risk.